Hey everyone, welcome back to another video. In today's video, we're going to be talking about parabolas that are written in vertex form, okay? And before we actually even show you what vertex form is, we're going to talk about the three numbers that they use in vertex form so that when you see vertex form, you're not too alarmed by it. So let's go ahead and let's get started with the first number that is involved with vertex form. So here I have a regular parabola. And really the first number that we're going to talk about that's included in vertex form is often referred to a, and it's usually in front of the x squared, okay? And what this number does, okay, when we change this number, it controls a few things. Number one, it's going to control the direction in which the parabola opens. So if this a number, so for example, let's say we had just f of x equals 2x squared. If it's positive, we're going to have a parabola open up in the upward direction, kind of like this one. If I were to have a negative number in front of my x squared, so let's say negative 2x squared, I would have a parabola that opens up downwards, as you see here in blue. Okay, so that's one of the first things that this number, this constant or this variable a, changes about our parabolas, whether or not it opens upwards or downwards. So remember, positive will mean it's going upwards, negative will mean it's going downwards. Okay? All right. So the other thing that this number can change, okay, is how wide or how thin our parabola is. If this number is bigger than 1, the bigger the number it is, the thinner your parabola gets. Okay? So let's say if I have f of x equals something like, let's say 5x squared, you're going to see a much thinner parabola than the one drawn here in red. Okay, the bigger the number, the thinner it is. All right, so that's one thing it does. The other thing, okay, if you want a wider parabola, all right, let's say I want a wide parabola, then we have to choose a number that's smaller in between 0 and 1. And the smaller it is, or the closer it is to 0, the wider it'll get. So if I choose something like maybe 0.5x squared, you'll see that we end up getting a parabola that's a bit more wide. And this is one of the first numbers, okay? This is one of the numbers that is included in vertex form that you want to make sure you know how this number works, okay? So far what we've covered about a is that if it's positive, it means it's going to make my parabola open up upwards. If it's negative, it's going to go open up downwards, okay? If it's bigger than 1, it's going to be thin, and depending on how big it is, the bigger the number, the thinner it gets. And then if we want to make our parabolas a little bit wider, we would have to choose a number between 0 and 1, okay, where the closer you get to 0, the wider you're going to get your parabola. So that is the first number. You'll see it as a. That's what this letter or number can change. Now, the other thing that most likely we like to do with parabolas is either we like to shift them to the right or to the left, okay, depending on what type of parabola it is. It might be shifted to the right or to the left. And the way we can tell which way it was shifted is by what number is written inside a set of parentheses being squared with x, okay? So we call this number h. H is what's going to control the horizontal movement of our parabola, all right? Now, one thing to be careful about this, though, is let's say I have something like this. This number is either going to decide if my parabola was shifted to the right or to the left. And let's say I have something like this, x minus, I don't know, we'll choose 3. 3 squared. Okay, x minus 3 squared. So, most often, people will look at this and say, oh, a negative 3. If this number controls whether or not my parabola is moving to the left or to the right, negative 3 makes me think it's going to the left. Which, it's a logical assumption considering that negative 3 is on the left side of my graph from the x-axis. But in reality, this one we have to be careful with because this 3 is actually, whatever number is written in here, it moved in the opposite direction of that. So if I see a negative 3, instead of me thinking it went to the left 3, it actually means it went to the right 3. Okay, so this would look like a parabola that was actually drawn here. Okay, it's like if we got a parabola and we slid it to the right 3 spaces. If I want to move something to the left, well then instead of doing a -3, I can try a +3. And this is actually a parabola that was shifted to the left 3 spaces. So this one would actually be right here. And that's all H does, okay? H will move your parabola from the left, or it'll move it to the right, okay? Now there's one more that we need to talk about, and that is K. K is often seen outside a set of parentheses, not attached to X, and it'll look like this, X squared plus K. And K controls whether or not how far up or how far down our parabola is going to move. And this one is actually not like H, the last one, the left and right movement, where it's going to be the opposite of what we see. This one's going to be exactly what we see. So if I see something like X squared plus 3, this means I had a parabola that was moved up 3 spaces. If I see something like f of x equals x squared, let's say something like -2, that means I had a parabola that was moving down 2 spaces. Like there in the green, okay? So these are the 3 values, or the 3 things that can change in vertex form that we want to make sure we're aware of how they work. Okay, so now let's actually look at vertex form to see all these things put together in one equation. So here is vertex form. Okay, vertex form is the equation f of x equals ax minus h squared plus k. That is my equation for vertex form. Okay, where A is going to control where my parabola is facing upward, downward, how wide and how thin it is. H controls whether it moved to the right or to the left. Okay, and K is going to determine how far up or how far down it was moved. All right, now if you watched the last video of terms that we learn when we're dealing with parabolas, one of the terms we talked about is the vertex, and that's kind of where does your parabola change directions, or some people call it the starting point of the parabola. Okay, the nice thing about vertex form is that if you know what H and K are, you know your vertex, because your vertex is actually H comma K. Okay, H comma K. So we're able to tell what our vertex is just by looking at an equation that was written in this form. And we also know what our axis of symmetry is. Okay, our axis of symmetry, again, we talked about that in the last video, so if you don't know what that is, check out that video. But the axis of symmetry is just H. X equals H. Okay, so we're given quite a few information when they give us a parabola that's written in vertex form. So now let's go ahead and look at a couple of equations of parabolas who have an equation written in vertex form to see if we can get any information from them. Okay, so we're going to see if we can find the vertex and the axis of symmetry just by looking at an equation written in this form. So here I have my first equation. Now what you have to remember is that your vertex, so our equation is written in the form of f of x equals a times x minus h squared plus k. Alright, so we can see it definitely mirrors that form, so we could automatically assume it's written in vertex form, and I can actually just compare them and see what they plugged in for A, H, and K. I can see that my parabola, the A is going to be 2, H. Now you look at H and you see, well, the vertex form normally has negative H, and they got a positive 1 here. So what did they plug in order to make it a positive 1? What did they have to plug in for H that would make it into a positive 1 down there. How do they get that? The only way to do that is if you were to plug in a negative number. If I do x minus a negative number, that would make x turn into a positive. The subtraction turned into a positive. So I know that they plugged in a negative number. So I can assume the only way to get that would be if they plugged in -1. And k is pretty easy. The only way to get k is if you plug in 4. Okay? So now, knowing that this is in vertex form, I know that my vertex is h comma k, which in this case is -1 comma 4. And that was done just by matching h to h and k to k. I also know that my axis of symmetry is x equals -1. Because your axis of symmetry is always just whatever the x value of your vertex is, okay? It's just going to be that number. Now what we're going to do is we're actually going to go into Desmos and we're going to graph this so that we can verify that we do have a parabola that is shifted sort of, because I can tell just by looking at this. I want to make sure that it does have a vertex at -1 comma 4 and that its axis of symmetry is actually at -1. So we're going to hop over there real quick. If you've never used Desmos, it's definitely a very handy site. Okay, definitely recommend it. But what I've gone ahead and done is this is what the parabola would look like if we didn't move it at all. Now let's actually graph the equation that we have, which was, again, 2x plus 1 squared plus 4. So we're going to do 2x plus 1. Oh, that's x equals 1. X plus 1. And we're going to square this. You can do shift 6. That'll allow you to get to the exponents. And then we're going to do plus 4. And I can see that my vertex is definitely at -1 comma 4. And the axis of symmetry is definitely here at x equals -1. We can see how the graph just literally got pushed up and moved to the left just a little. Okay, which is what, again, hopefully you can see that by looking at you can picture that in your head just by looking at the equation written in vertex form. All right, but this is vertex form. This is how we use it to get some of the information that we need when we're talking about parabolas. So hopefully now you won't find it intimidating the next time you see an equation for a parabola that's written in vertex form, okay? Hopefully you'll be able to look at it and automatically identify, hey, this is my vertex. This is my axis of symmetry. I can tell, kind of picture that this parabola is moved to the right, up. I know it's going to open upward, downward. You know, these are all nice things to be able to do, and that kind of calm us when we know exactly what we're working with without having to graph it. Definitely makes math a little bit easier and funner. As always, I hope you learned something. Thanks for watching, and I'll see you guys next time.